Oh, there it is. Trying to. Okay, so brief calculus basically asks you, okay, do we think we need calculus here or do we not? And that's you kind of get a picture as to why it's important, at least for physical, real world problems. So let's look at this first example. Let's consider the following. Find the distance traveled in 26 seconds by an object traveling a constant velocity. So on this guy, if we're traveling at a constant speed of 30 feet per second, do you think you need calculus for this?
No, because it's constant.
Exactly, right? So since it's constant, this is something that you can just multiply yourself and say, oh, I'll just take the 30 because that's my rate. Constant rate is the key word. Multiply by 26 and I'll have my answer. So we didn't do any fancy calculus stuff. We really just used algebra, which they wrote here, pre-calculus, etc. So if the function was complex or had variables in it, then it is not a constant rate. If the velocity had a function instead. I think number 2 here has it. So check it out, the difference. So the velocity of this object is modeled with this 20 plus 8 cosine t. So this is no longer something you can do in your head and just say, oh yeah, that's just 50 times whatever, right? 50 seconds. No, it's different now. So because it is a function, then we would need we could possibly need calculus depending what the question is asking. So right now it says find the distance traveled, and I'm given a velocity function. Let's try it out and see. Do I need calculus? Yeah, because it's not a constant. Over here, no big deal, right? Does that make sense? Like as to why you need calculus and why you don't?
Yes.
Okay. Let's see here. Consider the following problem. A bicyclist is riding on a path modeled by a function, f of x equal to 0.07x, where x and f of x are measured in miles. Find the rate of change of elevation at x equal to 2. Okay. So here's my function. It's a linear function. What do you guys think?
It can be solved using pre-calculus.
Yeah, I think so too. Because it did say, as soon as I saw rate of change, we think back to high school algebra or college algebra. We think, well, when we had lines, that was just called the slope, right? Do you remember that? Back in the day, the rate of change of a line is a slope.
Yeah, y equals mx plus b.
Yeah, exactly. So the m is right there. 0.07. So it'll be the same rate at any x because it's just a slope. It's not a complicated function. So I don't think I need it personally. But check this guy out. This is no longer linear, right? So that means that there's no constant rate. The rate changes depending where I'm at, because check this out here. From here, let's say 0 all the way until 3, I'm increasing on the graph, right? But then right after, I'm beginning to decrease. So over here, I was just increasing at a constant rate. So it was no big deal. I did not need calculus. Here I do, because the rate of change is actually a function. It is changing at every x. So the rate changes. So at one point it's positive, increasing, another point it's decreasing. Maybe there's a point where it's constant, but It is not the same throughout the entire function. So that's why I need calculus. Does that make sense?
Yeah.
I mean, there's not much to actually solve by hand. It's more of a conceptual thing. So I want you to see that idea. Okay. Here's another idea. We're applying it to area. So on part A, do you guys know how to find the area of a triangle?
Isn't it?
Isn't it like length times? Wait, no, that's a fucking square. Never mind. I was about to say length times.
Well, no, you're not wrong, or you're not too far off, right? Half of a square is a triangle, right? So
Right.
it'd be length times width times a half.
Oh, okay, okay.
So yeah, so most likely all of you could figure out how to get an area of a triangle, right? We don't need calculus for that. You agree? Because it's a geometric shape. We can use geometry. We can use old school quick maths. Part B, that's a weirdo shape. Has a curve on it. So I could maybe approximate it with geometry, but I cannot get the exact area. I could maybe like shove a little line in here, make a square, but getting this top part, not so much, right? So this is when you need calculus. So part B you do, part A you don't. Okay. Does that make sense?
Yes.
Okay, so that's the big picture for a preview of Kyle. So I'm hoping this section is not too bad. So let's look at 2.2 now. It starts getting a little more difficult. Let's see if there's actual stuff to solve by hand or not. Okay, so here we start talking about limits. So limits is very theoretical. It's how do I put this?
2.2 is grayed out for me.
It came out.
2.2 is grayed out. I can't click on the link.
Oh, let me see what's going on. 2.2. Oh, I think you need to click on the video first and then it opens. I think it might have a prereq.
Oh, yeah, no, that's what happened. Yep.
Okay, cool. Yeah, I think a long time ago I think last semester, yeah. I added prereqs to try to encourage people to watch them, but I'm not going to force you. All right, so limits is very theory heavy. If you're not a math major, you're not going to see limits very much at all. But the concept is kind of interesting. So basically the idea is there's a number on the function that I can't actually go to, but I can get infinitely close. So the limit can be defined, but not the value. Let me give you a picture. 1 second. Yeah, let's use a pretty grapher because I can't graph worth a damn, man. Give me 1 moment.
What's that?
Okay, can you see the graphing utility?
Yes, sir.
Oh my god, I love Desmos.
Yeah, Dylan's really nice. I highly recommend you all use it, especially
It
for
is amazing, y'all. Yeah, y'all should use it. It's awesome.
like especially for chapter 2.2. It's gonna be quite handy. So let's graph this guy. Let's call this f. So f of x equals x minus 4. What's the rest? Excuse me. Minus 5x plus 4. Okay. So notice how every point is okay on this function, right? Except looks like 1, right? Now, if we factor it, we might be able to cancel something. Let's do that first real quick. That was number 1, right? 2.2. So f of x equal to x minus 4. We'll get back to the graph in just a second. So if I factor the bottom, can we factor it? Does it factor nicely?
Yeah, I think it's x minus 1 and x minus 4.
Yeah, it looks like it. So that means it's going to cancel this guy, right? You see that? So we have division by 0 at x equal to 1. You guys see this? So that's where the hole is. So there's a hole, like we said, at x equal to 1, and that's the reason. Because I can use algebra to get rid of the other hole at 4. This is called the removable discontinuity. See, it's technically not defined right there. So it is a problem, but it can be filled with algebra. The 1 cannot be. It never touches 1. It gets infinitely close, but never actually touches it, never crosses it. It's a vertical asymptote. But what limits lets you do is approach that value and see, is it defined? Same thing with the 4. 4 is like, well, it's technically not defined, even though it's removable. So there's a couple of techniques to find a limit, right? So the limit, that's something you can do, is approach the limit from the left side. So get really close to the 4. Let's see, they told me, they didn't ask about the 1. They asked about the 4. Okay, so when they say, let me put this in English, plain English for you. So the limit as x approaches 4. I'm gonna write down what this question is asking you to do. Okay. So basically, what is the y value as you get closer and closer to 4 from both sides? That's what it's asking you to do. That's what this means. Okay. So you can do it graphically. Let's get back to the graph. All right, so I'm going to put another point there so you can see it easier. X equals 4. So there's 4 right there. Usually it clicks the intersection, but that's okay. Anyway, so I'm grabbing this point. So from the left direction, as I get closer and closer to 4 on the x-axis, what is my y? What are the y values doing? Do you see them?
Going 3.
Looks like it's going to 0.33, right? And as I approach 4 from the right-hand side, what's happening to the y values?
It's increasing.
Yeah, and they're getting closer to the same number, right? 0.33. You see that? So from both sides, I'm approaching 0.33. But technically, when I get there, it's not defined. So I'm not allowed to go to 4, but I can get really close, infinitely close. That's the idea of limits. So I can use this idea of infinity to just keep trying to get closer and closer. So what you're going to do in this homework is plug in 3.9, get the value, the y value here, 399, put the y value here, 3999, you put that there, and then you're going to say, well, it's getting closer and closer to 0.33 whatever.
Can you say how you did that? How you find the answer one more time? I'm sorry.
So there's many ways to do it. So one way is to plug in the numbers, right? And get closer and closer to the 4, because that's what it's asking, right? What happens to the function as we get close to 4 from both sides? They have to be the same. So this will give me the left side, closer and closer. From the right side, getting closer and closer to 4, but I'm not plugging in 4. And you plug in the results here. And then these will give you the answer. Now, graphically, though, I think that's what you're asking, right?
Yeah, that's what I was about to say. So whatever the X is, and you'll plug the answer in for whatever the Y is on that one when it matches.
Yeah, so you'll basically check what's happening on the left and see what the y values are doing.
Yeah.
It's getting closer and closer to 0.33, right?
So how many significant figures do we put it as in the homework? Does it matter?
They want 4.
Okay.
So their answer will be like 0.33, I don't know, 8 something. I'd have to plug in the numbers. So when you plug this guy in there, you'll see it more clearly. Let's see if we can do that over here. F of 3.99. So it looks like 3334. So you'd say 3334. Let's see if it likes it or not. Yeah. But you'd have to plug in you'd have to do each of these for full credit. Okay. But you will see that you're getting closer and closer to this number as you plug these in. Does that make sense? Like what it means graphically?
So I understand the part where you're getting the y-intercepts, but that
Mhm.
part where you got the 0.334, how did you know which one you're focusing on to put that as the answer?
So as you do one of these as you do these numbers one at a time, you're getting closer and closer to this number. So you're gonna see it as you do these steps. I went ahead and did the last one because that's the one that's closest. These two are closest to 4. So I figure these are gonna be
Oh, okay. I see what you're saying. We're putting in the answer for the one that we didn't have.
right. So this one right here is 0.3334. Oops, my decimal didn't pop up. When I do f of remove 19, that's going to be 3344, right? So that's going to be 0.3344. Just 19, that will be 0.3448. So you see how it's getting closer and closer to this answer. Oops.
I have a question.
Mhm.
So in order to do this, do we need to download that program or whatever you're using?
No, you can just use a calculator. You would plug you would plug these numbers into here. And that'll be the
Okay.
result. It's a little easier to do it on the website just to save time.
Mhm.
But any graphing calculator or scientific will do it. You'll just have to type it in. If you're to do it by hand and then use a basic calculator, you would do this. You'd say, okay, well, f of x is equal to this guy, right? It's okay, well, what the heck is f of 3.9? Well, I have to plug it in. 3.9 minus 4 over 3.9 squared minus 5 times 3.9 plus 4. So you would do all this, and then you would get approximately 0.3448. Then you do it again. F of 3.99 and etc.
Oh, I see. Okay. Yeah, it's easier to just get that. Okay, thank you.
Yeah, I mean, this is what's actually happening. I just used that other method because it was a lot shorter, right? But yeah, if we do the exam on respondents, then I'll make sure you have access to Desmos. It's not a big deal. Any questions on number 1? Does the concept make sense as to why the limit is 0.3334? So remember, the limit only exists if it's the same thing on both sides. So when you're coming from the right, it better be getting closer to this number. If you notice that it's different over here and different over here, then there is no limit. Okay. You would only have one-sided limits. You have this limit on this side and a different limit over here, but you don't have a true limit. Notice how it just says x approaching 4, right? So both sides needs to be the same. I don't think we have one directional yet. Let me see. Yeah, it's not till later. You guys cool on number one?
Yes.
Yes, sir.
Yeah, number
Basically,
2 is the
number it's
same.
getting closer to.
I'm sorry, what's up?
Basically, it's just the number it's getting closer to will be the constant.
Yeah, so whatever number you're approaching from the left side and right side will be your limit. And the number you're looking at will be whatever is right here, right? That's why 4 is right there. So in the next one, we have x approaching 0. So we're going to look at the function and see what's going on around 0. So we plug in numbers getting from the negative side, getting really close to it. Or sorry, I should say left side. Because this wasn't negative. This one is. And then from the right side. So we're going to plug in the numbers for every single one, either in the graphing calculator or scientific or Desmos, and then find out what it's approaching. And it should be approaching, I think 5. Let me see if that's right. Yeah, be 5. Well, let's visualize it because we need to see what the heck's happening. So we had 5 sine x, right? Over x. So we want to know, you guys can see my graph, right?
Yes, sir.
So we said as x approaches 0, what is going on the left side? So here's 0, just to make it easier so you guys can see. X equals 0 is the purple line. So from the left side, what are the y values of the sine function or of f of x? What are they approaching as I get closer and closer to x equal to 0?
Approaching 5.
Yeah. And then from the right, is it the same?
Yeah.
Since they are the same, the limit exists and it's equal to 5. Even though the function is technically not defined there. You see the hole? So you can't actually plug in 0, but you can find the limit from right side and left side. That's what limits do. They let you go, they let you kind of find out what's happening at a certain location by incorporating like ideas of infinity. So we get infinitely close to a hole and we kind of just see that it's 5. Does that make sense?
Yes, it approaches the number, but it just never exactly intersects.
Yeah, it never actually gets there. That's why we're saying the limit is 5. but the function is not equal to 5. It's undefined. If you plug in 0, you'll get an error. Just like over here, if I plug in 1, I would get an error. I'm sorry, 4. It probably wouldn't work. Okay. Are there any questions as to how to do these?
Oh, Professor, I have a question.
Mhm.
It's not about how to do the problem though. Is there a way we can like do our homework and like say we need to stop and come back at a later time? Does it
Yeah,
save it?
it's not timed. You just hit save and close it.
There's a
Oh, okay,
button at
good.
the end that says save your whatever work you've done and then let you come back later.
Oh, okay. I haven't used this program with math yet, so that's why I was asking, like, do I have to do it in one setting or?
I think as soon as you hit submit, like I did, like these will be saved.
Right. Oh, okay. I got it. Thank you.
Yeah. So I recommend as soon as you finish a question, just hit submit and move on. It should be good. Okay, what else is on here? So this is the same deal. We'll let you guys work on these. Number 5. Use a graph to find the limit. Okay, well, this function is 3 minus x. What is the function doing as we get closer and closer to x equal to 2?
It's decreasing.
It is decreasing from the left. But what are the y values doing? What y value am I approaching?
Is it,
One.
yeah,
1, right? So that's what we're looking at when we do function, or when we do limits. We want to know what is the y approaching when I look from the right side and the left side, right?
X never matters during all this. It's always just looking at Y.
Yeah. So we're approaching some x value on the function, and we're trying to see what the y is doing. That is what the limit questions are asking you to do. That's what we did over here. We looked at the function and we approached that 4, which was the x value. And these are all the y values that we're approaching this. And this is approaching 5, right? Does that make sense? Okay. Alrighty, let's check out this type of example. To consider the following. So this is a piecewise function. I'm sure you remember seeing these from college algebra. So they basically connected 2 functions together and made some, told you where they're defined. So we have a parabola everywhere, except when x is equal to -1. So it's not, the parabola is not defined here. When we do get there, this bigger function is equal to 2, which is down there. So if I take the limit of this big F here, this piece, these 2 pieces put together, if I go from the left and go from the right, what y value am I approaching?
3.
3, right? Although
Yes.
the function is defined there at 2. So the function is equal to, it's equal to 2, but the limit is actually 3. Let's see if it works. Does that make sense? This is kind of like a weird trick question because it is actually doesn't have a hole over here. So f of -1 is equal to 2, but the limit is equal to 3. Are there any questions about this? And that'll become more important when we get to continuity. So this function is not continuous there, but it is defined there, and then there is a.
the way you're showing us right now, will these be on the tutorials as well?
These are all your homework questions that we're going
Right,
over.
yeah, that, the reason why I asked is because I like to go back and continue watching references whenever I do my homework. So I was just asking if it was gonna be on the tutorial since, you know, we can't always be with you like personally.
Well, I'm gonna upload the video for what we're doing right
Okay.
now.
Okay,
They do have similar examples, I believe. But your question will be exactly the same. They just these numbers will be different.
right, gotcha.
And since we've
So
talked about
how
all
would-
of them, we should be good. I hope. But you can always let me know.
So
So
what?
that's when we did. Would we have to solve one like that? What if we didn't have the graph? Like, if we had to do it by hand, like will there ever be a situation like that?
Like, if you don't have this graph,
Yeah, if you just had to do it by hand.
yeah, if you did it by hand, you'd have to do this approach right here. You'd plug in numbers closer and closer to the limit that x is approaching.
But since it's two parts, would you just plug in the number that x for both sides?
Yeah, so let's say I was doing this one, right? And I didn't have a graph, so I would plug in 2.01, 2.001, 2.0001. Then I would plug in 1.9, 1.99, 1.999, and see what number I'm approaching, and that'll be my limit. So you just plug in numbers closer and closer to 2, but don't plug. You can't use 2, so you just plug in numbers really close, and you'll see the numbers on your calculator approaching something.
Yes, sir.
So you have 2 ways so far to solve these. You have a computational approach by plugging in numbers, and then you have a graphical approach by just looking at the picture. There's 2 different ways so far. Does that make sense?
Yes.
Okay, the next one wants to know what is a limit when approaching 5. So here's 5, right? Notice that the limit from the left is not the same for the limit on the right. You see this? When that happens, there is no limit. It does not exist. Both sides need to be the same. Otherwise, there is no limit. Okay.
For that last one,
Mhm.
they're not. I understand that they're like Danny, but like those other ones, they're touching, but they're still open circle, like little dot. It's like not full. They're still counted as line.
Yeah, I think they have a hole. They're talking about the holes, right?
Yeah, so like if it was connected, it would be like it would actually be a limit, or would it still not be a limit because the dot?
Yeah, even if one of them was filled, it wouldn't. The limit would not exist.
Or
In a,
because they're just not connecting completely, right? Even if for both.
I mean, if it was
dots.
connected like this, then yeah, you can kind of see for sure there is a limit, or like this guy.
Mhm.
But these are literally going to 2 different places, so no. So basically, and this is the notation which we'll talk about later. Oh well, I guess we'll get there in a minute. So if we were to do this by hand, consider the following. So let's say our function is this thing from the homework, right? So the notation, the limit as x approaches 5 from the right side would be plus. So if you see this notation, a little plus on the upper right, they're asking for the limit from the right. And then that's this guy, limit of this guy. The limit as x approaches 5 from the left side, the negative side. So these need to be the same. The right and the left need to be equal in order to say that this actual limit exists. So let's look at it. From the left, what is that number? Can you see? I can't see it.
What is it, like -1?
I think so.
Yeah, I think it is. Because it'd be -1 and then like -1.5 and then
Yeah, I
-2.
think you're right. Okay, so from the left, we have, so from this side, the left side, the negative side, we have -1, right? From the right side, we have +1, correct? So in the videos and in the notes, there's a definition that says that the limit will only exist if the limit from the right and left are equal. So as soon as you see that they're different on both sides, you say the limit doesn't exist. Okay. You write that a little better. Okay. So if these are the same, then this exists. Let's put it in plain English, since the limits from the right and left are not equal, then the overall limit doesn't exist. In the question, they don't have a symbol of plus or minus, right? Did you notice that? It's just 5. So this is just a regular limit. They want to know this will only exist if both sides are the same. And they are not. Now, do you see this one? When I approach 0, which is right in the middle, from the left side, what am I approaching?
4,
And from the right side, what am I approaching?
0.
They are not the same, right? So that also does not exist. They have to approach the same thing on both sides. Just like this. They're approaching 3 from both sides. Approaching 1 from both sides. And these two we graphed, and we saw that too, right? Approaching from both sides, we were getting to the same point. That's why the limit existed. Does that make sense?
Yes, sir.
Okay. So the limit definition is very when you watch the video, you're going to see it looks very complicated, but as you see when we do it together, it's a simple idea, like when you can see it visually. But the analytical side is very confusing. But this is all you have to do. It's just basically look at the graph or look at what's happening to the function as they get closer and closer to those values. Okay. Let's see here. Let's do number 10, I guess. So they want to know what's happening at 1. 1's right here. So if I plug in 1, what's the value of the function based on this graph? Can you see it?
What do you mean if you plug in the value of 1?
What is the y value when I plug in 1 into this function?
Oh, it's
Here's 1 right there.
Would it be two? It looks like there's multiple, but I think two because it's a full.
That's what I was
Yeah.
gonna say.
Yeah, these have holes. So the only point it's actually solid on is 2. So you guys are right. Now, let's look at the limit. Is the limit the same as the functional value? Is it equal to
No.
2?
No.
No,
think
right? It actually
the-
doesn't exist, does it?
Yeah.
Yeah, they're not the same from left
Yeah.
side or right side.
Because they don't have to be the same in order for it to have enough, the limit, right?
Yeah, they have to be the same in order for the limit to exist. So does not exist because they're different. Let's look at 4. Here's 4. Is the function defined at 4?
No.
No, there's a hole, right? So the function is not defined. But what about the limit? Is it the same on both sides?
Yes, sir.
Yeah, it looks like it's approaching 2, right?
Yeah.
So the limit exists, but the functional value doesn't exist. Over here, we had the functional value existing, but the limit did not exist. So both scenarios can happen. Is there any questions about that?
Yes, I'm kind of confused as to why,
Mm-hmm.
or the difference between limit and the function.
Well, the limit is defined by what happens when you're approaching the point from the left side and right side, right? So let's look at D. So when I'm approaching 4 from the left, the y values are going to 2. When I approach from the right, the y values are going to 2, right? So that's the definition of the limit. They must both be the same thing on both sides. As I approach them, they must approach a single y. And if they do, that's my limit. But the functional value has a hole in it. I can't actually plug in for, right? So there's a hole there, but the limit exists because I can get infinitely close, but never actually get there. I can't actually go there because of the hole. Kind of like this guy over here. Remember we said there's a hole right here, right? But we can approach the 5 from both sides. Approach the 5 from both sides. But I can't plug it in. It is undefined because there's division by 0.
Okay, that makes sense.
So yeah, so that's why it's undefined. So sometimes, depending on the graph, right, there might be a reason why I can't plug it in, but the limit may still exist. So you can still see what's happening. You just can't actually go there. Is there any other questions on number 10? Alrighty. So I want you to start trying some of these problems and let me know if you get stuck. So if you want to go straight to 2-2, that'd be cool. If you want to do 2-1, that's fine. So with the rest of our time remaining, I want you to start working and ask me questions if you get stuck. Okay.
So just,
way you
we're gonna do
can-
like homework time in class and then ask for questions.
Yes, please.
Okay, cool, great, that works.